Welcome to Unit 3. What do we do today? Well, we start modal logic, which is kind of a big section. And before you go through this unit, I suggest that you read 4 pages from our book. Okay, so modal logic. This will be our third major system of logic. Our first one was syllogisms. You had things like all A is B and some A is B. And this system goes way back to Aristotle and is part of so-called traditional logic, although we didn't study it in a very traditional way. Then our second system was propositional logic. This is the core system of modern symbolic logic, and everything else in modern symbolic logic builds on it. And there's another system which is part of the classic systems of symbolic logic, and that's quantificational logic. And we're skipping that because of classes lost on the transition to online instruction with the virus. So you would have had something on that. That's in the book if you want to look at it. Instead, we'll be taking modal logic, which is a more recent logic. It's often considered a more advanced system of logic. So very few introductory logic courses would cover it. I love modal logic, though, and it's really easier than quantificational. Why do I love modal logic? Well, because of its philosophical arguments and issues that it raises. There's a lot of really classic and important philosophical arguments that are modal in nature. For example, the divine foreknowledge, human freedom argument. And we will see these as we go along. What is modal logic about? Well, it's about necessity and possibility. And it builds on propositional logic. So, like before, capital letters stand for whole statements that are true or false. And so also with modal logic. And also you have symbols like not, squiggle. You have horseshoe for if then, and you have S and I rules. You have rules for proofs, and you have multiple assumption proofs, and everything else of propositional logic you incorporate into modal logic. Modal logic just adds some stuff to basic propositional logic. It adds 2 new symbols. There's the diamond and the box. The diamond means possible. So diamond A means it's possible that A. The box means it's necessary that A. These were at one time considered modes of truth. So, so you could be true. That's just A. But you could make a weaker claim that it's possible that A is true. You're not saying that it is, but just that it could be a very weak claim. Or you could make a very strong claim that it's necessary that A. It has to be, not only is it true, but it has to be true. Okay, let's look at these 2 approaches now. First of all, possible A. If you say A could be true or A is possible. Now, the word possible could mean different things. You could mean legally possible. In other words, there's no law against it. You could mean morally possible. It's permissible. You could mean it's physically possible. It accords with the laws of nature and biology and stuff. You could mean logically possible. That's usually the last one. Logically possible is what we will mean in modal logic, at least most of the time. An idea is logically possible if there's no contradiction in it being true. It may go against the laws of nature, but it's still logically possible if there's no contradiction in it being true. For example, suppose I say it's possible for me to run a mile in 2 minutes. Now, if you've ever seen me run, you know I'm pretty slow. Is it possible for a human to run a mile in 2 minutes? It's not physically possible, probably. Probably if you train and train and train, you'll never be able to run a mile in 2 minutes. No one would be. So it's not, but it is logically possible. You could write a book in which your teacher runs a mile in 2 minutes. It's logically, there's no contradiction in the idea. And that's what we mean by the diamond in modal logic. It's possible that A means logically possible. There's no self-contradiction in the idea. Now, another way of expressing that is through the notion of a possible world. What's a possible world? It's you can visualize it as a story about what may be or could have been, in which all the statements fit together. There's no contradiction, but they're not necessarily true. So you could write a consistent story in which your teacher runs a mile in 2 minutes. So A is true, that is true in some possible world, and maybe not a very plausible possible world. So if someone says, well, I can do that, and you say, well, in what possible world? Maybe questioning whether it could happen in the real world, which is somewhat different. So possible is a very weak claim. It just claims that the idea has no self-contradiction in it. Now, necessary, by contrast, is a very strong claim. It's necessary that A means its denial is self-contradictory. So if you say x equals x is necessary, that would mean that its denial, x doesn't equal x, is self-contradictory, which it is. Another way of saying that is what's necessary is what's true in all possible worlds. Now, not very much is true in all possible worlds. Presumably, things that are true as a matter of logic or conceptual. Like if you say, if there's rain, then there's precipitation. That would be logically necessary. If there's rain, then there's precipitation, because rain counts as precipitation. That's the way the concepts work. So you have necessary, true in all possible worlds, and you have possible. And in between, you just have the normal idea of truth, which we've been using so far. So if it's necessary, then it has to be true. And if it's true, then it has to be possible. Now, this idea of possible worlds is very useful for visualizing what the formulas mean, but also for doing proofs. We will see that later. And the idea of possible worlds goes way back. One of the first few to use it was Leibniz, who also was during the Enlightenment period, and he also invented calculus in his spare time when he wasn't doing logic or metaphysics. Leibniz famously claimed that this is the best of all possible worlds. Why? Well, because God had a choice of creating all kinds of possibilities, and being a good God, he would create the best one, and being all-powerful, he'd be able to do it. So this is the best of all possible worlds. Now, other people have ridiculed Leibniz on that account, and that's a long story. That's for another course. But he used the idea of a possible worlds, and philosophers use it a lot these days. Schopenhauer was a later philosopher who thought that this was the worst of all possible worlds. He was a very gloomy sort. He thought if it was any worse, it would cease to exist, which would actually be better. Poor guy, not very happy. So now our first task is to figure out how to translate from English to modal logic. And how do you form WOFs, or well-formed formulas, in modal logic? Well, the all the other ways of forming WOFs work. So if you have a capital letter, if you have a not in front of a WOF, if you have A dot B where these parts are WOFs, those are all WOFs. Okay, and there's a new way of writing a WOF. The result of writing a diamond or box and then a WOF is a WOF. So possible A is a WOF and necessary A, or you could have if necessary A, then possible B or C or whatever. You can do more and more complicated WOFs. But the thing to note now is if you're just doing possible A and necessary A, you don't add parentheses. So it would be wrong to say possible parentheses A, parentheses around the whole thing. That's really bad. No, don't do that. Just keep it simple, and there you go. Now, two of the more common ones are A is possible, consistent, could be true, various ways of saying the same thing. And we will regard these as all equivalent. And that just goes into diamond A. Okay? A is necessary would go into box A. And you could also say must be true, has to be true. Again, we will regard these as just different ways of saying the same thing. And again, these don't use additional parentheses, really no need. Now, impossible, you could express in two different ways. You could say not possible A, or you could say necessarily not A. A couldn't be true, or A has to be false. A is true in no possible world, or A is false in all possible worlds. So impossible or self-contradictory, you could put two different ways, and it really doesn't matter a whole lot which one you use. Okay, now our first task is how to translate from English into logic. And here are some kind of simple examples. You'll see these cases a lot. And so you have A is consistent with B, means it's possible that they're both true together. So A is consistent with B means not possible A and B together, or possible A and B together. And you could also say, you could imagine a possible world in which A and B are both true. Okay, there you go. Now, a variation on this is possible to, if you say A is inconsistent with B or incompatible with B, what would that be? It would be not possible that they're both true together. And that's often a common idea. Now, A entails B, that means logically entails. It means it's necessary that if A, then B. Okay, so it's like an if-then, but stronger. In all possible worlds, if A, then B is true. Or it's a matter of logical necessity that if A, then B. Now, most if-thens are not that strong, but some are. And if we want to express a strong if-then, then we have to use the box there. Let me give an example of the difference here. Suppose I say, if it's Saturday, then I don't teach. This is true. I don't teach on Saturday. In fact, I've never taught on Saturday in my entire life. But is it logically necessary? No. I could decide to teach on Saturday. I could talk my chair into assigning me to a Saturday class. It's never happened. Probably will never happen. So it's true that if it's Saturday that I don't teach, but there's no necessity in it. So you would not use the box. Whereas if we say it's necessary that if there's rain, then there's precipitation. Rain logically entails precipitation. That's a necessary truth. And it would be correct to use the box to symbolize. In all possible worlds, if there's rain in that world, then there's precipitation in that world, because rain counts conceptually as precipitation. Now, these next two are a little tricky. Contingent statement. If you say A is a contingent statement, you mean it could be true, it could be false. It's possible that A, it's possible that not A. If something is necessary, strictly speaking, it's also possible. That is, it's true in some possible world. So necessary, contingent statement is not the same as possible. It's the same as it could be true or it could be false. Whereas if you say possible, you're saying it could be true. Maybe it's necessary that it's true. Now, this distinction is stricter than in ordinary language, where people are sometimes fuzzy about the difference. But in logic, we take these terms very strictly. Possible is a diamond. If it's possible, it's true in at least some possible world, maybe true in all, but you're not saying that or denying it. Whereas if you say contingent statement, you say could be true, could be false, possible that A, and possible that not A. So you got to use that form. Now that's contingent statement. Now contingent truth says it's true but could have been false. If you say contingent statement, you're not saying whether the thing is true or false. You're just saying could be true, could be false. Whereas if you say contingent truth, well, then you're saying it's true but could have been false. So you're making a stronger claim. Be careful about that. There are, of course, logical exercises about translations to help you with that. So you will get adequately drilled into that. One general rule is that when you go from English to logic, it's usually good to mimic the English word order. So if you say necessary not, the box is first. Necessary, squiggle. If you say not necessary, then the necessary is second. It's kind of like with propositional logic. If you say not both, the both is the parentheses, and the not is the squiggle. Whereas if you say both not, then it's like that. So the box is the necessary, and the not is, so the box is necessary, the not is the squiggle. And follow the English word order. And the same thing is if you have necessary if. Then you have box, and the if is the left-hand parentheses, if you remember that from propositional logic. And if necessary is, if, again, is the bracket, parentheses, necessary is the box, and where you go. Oh boy, what am I doing here? I hit the wrong button. So, haha, not doing too bad though. So, another nice rule is delete. Let's get rid of this. Is each necessary or possible uses a separate box or diamond. So if you say, if A is necessary, box, if necessary, A, and B is possible, diamond. If A is necessary and B is possible, then C is possible. So you have the if then, C is possible. So each necessary and possible use a separate box and diamond. These are two good rules. They will help you along. This one doesn't always work. There's a notorious problem where you don't mimic the English word order, where it's more complicated, but we will get to that in a little later. So, okay. Now, our first exercise. Go to page 233, and this is our first translation exercise. And again, as usual, the book gives you a sample problem that it works out just to give you an idea. So you have God exists, G, and evil doesn't exist, entails there's no matter. So that would translate into that. That's the sample. Is that a deeply important philosophical issue? No, it's just kind of a nice example to start with here. Okay. Now, we're going to do a few problems. Let me do the number one. It says it's necessary that God exists. What will that be? Box G. Do you use parentheses? No, no, no. Box G. That's controversial. A lot of philosophers, even ones who believe in God, don't think that it's a matter of God existing of logical necessity. But some philosophers do think that. St. Anselm of the Middle Ages taught that the existence of God is logically necessary. God couldn't not exist. And he gave his famous argument, ontological argument. For that, we did that actually in propositional logic. According to his view, God is a being than which no greater could be conceived. And if you deny the existence of such a being, you get a contradiction. So it's necessary that God exists. But that's controversial again. And there you go. But our job is just to translate it. So I want you to hit the pause button and then translate 2 to 14 on page 233 on paper. So do that, work them all out. Look at the rules, try it, and then hit play after the pause, and I will explain the right answers, and we'll get into kind of a few little subtle things on that. So, okay, so now hit the pause button. Okay, so I wanted you to do a whole bunch of problems and then I'd go through it. And now I want to go through them, give you the answers and raise some questions and issues. There is a God is self-contradictory. That would go not possible, G, or you could say necessary, not G. You have to give them both? No, it's just two different ways of saying that. So there are people who hold that the existence of God is self-contradictory because they say the characteristics of God don't fit together. Logically, you can't have a God who's all good and all powerful because there's evil in the world, or you can't perhaps have a God that's all powerful because then he could create a stone so big that he couldn't lift it or something like that. I don't think those are good objections, But anyway, this is how you translate it. There is a God, you could, is self-contradictory. You could say not possible G or necessary not G. Again, just pick one. Now, the second one says it's not necessary that there's matter. Not necessary. Am. And this was held by St. Thomas Aquinas, who held that God exists of necessity, but whether or not there's matter depends on God's free choice. It's not necessary that there's matter. There happens to be matter because God freely chose to create matter. So the existence of matter is not logically necessary. You could conceive of a possible world with no matter. Okay, hope that's clear. Oh, Annie in the first row is raising her hand. What's your question, Annie? Well, the first one you could translate using a diamond or a box. Could you translate this using a diamond also, alternatively? Hey, that's pretty good. You're a pretty smart girl. You're smarter than you look. Thank you, I think. And okay, now how would you translate this, Annie, do you think, using a diamond? Instead of saying it's not necessary that it's matter, what could you say? It's possible that there's no matter. So, diamond, not M. You are absolutely right. Possible, not M. Again, those are two different ways of saying the same thing. It's not necessary that there's matter. Not every possible world has matter. There's a possible world with no matter. Okay, good. And the third one says it's necessary that there's no matter. Necessary that not M. And this was held by George Berkeley, who is an Enlightenment philosopher. He was very much against materialism, which would deny matter. But he went beyond just denying matter. He said, not only isn't there matter, but there couldn't be. The idea of independently existing material object is self-contradictory. He thought that the only thing that exists are minds and their ideas, and what we think of as independently existing matter isn't that at all. It's just a bunch of images in our mind. So he was sometimes called an idealist. There's no matter. And it's necessary. There couldn't be matter. Now, how would you express this using a diamond? Joey in the front row. How would you? Well, you could say not possible M. Right. Yeah, so you could say necessary that not M or not possible that M. And then fourth, there's rain entails there's precipitation. That's necessary. That if there's rain, then there's precipitation. This is widely held by weather forecasters. The notion of rain entails precipitation. There are other forms of precipitation, like snow or hail. Yeah, there are various forms of precipitation. Water coming from the sky, whether liquid or frozen, is something like that is precipitation. But rain would count as that, so that's necessary. Whereas 6 says there's precipitation doesn't entail there's rain. It's not necessary that if there's precipitation, then there's rain, because it could be snow or something else. And 7 says there's no precipitation entails there's no rain. Necessary that if there's no precipitation, then there's no rain. Is this true? Yes. This follows from this, actually. And so could we prove that? Well, not until next class. And then H says if rain is possible, so if possible rain, then precipitation is possible, then possible precipitation. So note that you got two possibles, and so you got two diamonds in translation. And 9 says God exists. That's just plain G. No boxes or no diamonds. Why did I put that in? Well, mostly because people tend to get box happy. They want to put boxes into everything. No, no, no. If it says necessary or entails or something like that, one of those modal ideas, then use a box. But if it just says God exists, no box. Now, 10 is a little tricky. I wondered how you translated it. Annie, how did you translate this? Well, I said it's necessary that if there's rain, then there's rain. I think I gotta work on my voice accents. Well, okay, that's one way of translating it. Now, Joey, how did you translate it? Well, I thought clearly that the must is it's just about the rain. It's not about if. So I translate it like this: it's necessary that if there's rain, then rain is inherently necessary. Now, tell me that I'm right and Annie's wrong. Well, I'm sorry. The problem is that this form, where you have an if-then, and you have a necessary in the second part, is ambiguous. It could mean in English two very different things. And these are called box outside or box inside. What's the difference? Well, the first one, it's necessary that if there's rain, then there's rain, is true, but it's utterly trivial. It doesn't say a whole lot. It's necessary that if A, then A. Okay, it doesn't say anything at all, but it has to be true, kind of trivial. Necessary that if R, then R, with box outside. Whereas this one says if rain happens at all, then it happens of inherent necessity. That's the box inside. Rain doesn't just happen. If it happens, then it happens of inherent necessity. This would be a form of fatalism about rain. So they're really very different. The first one says is kind of trivial. It says necessary that if there's rain, then there's rain, which is undoubtedly true, but doesn't say much. Whereas this one says if there's rain at all, then there's rain of inherent necessity. It couldn't have been otherwise. Second one is more meaty and more controversial. Okay, and I told you before we had a rule that it's good. Where was the rule? Right here. It's usually good to mimic the English word order. Okay, and that's true normally, but sometimes not. Sometimes there's a kind of an exception, and this is the exception. You have certain forms that are ambiguous in English and in a lot of other languages too. The medieval philosophers who used Latin complained that it was ambiguous in Latin too, between inside and outside form. I don't know about Chinese. I'm just learning about Chinese. But since my logic book is going into Chinese, the translators will have to talk about that, actually. Is this ambiguous? Okay. Suppose you say, if you're a bachelor, then you must be unmarried. This is one of the ambiguous forms. If, then, must. Now, does the must go on the inside or the outside? It means two very different things depending on how you do it. If you put it on the inside, it's called simple necessity. And this would mean if you're a bachelor, then you're inherently unmarriable. In no possible world would anyone marry you. You're just inherently, intrinsically unmarriable if you happen to be a bachelor. Okay, Joey, you're talking to one of your friends, and what are you saying? Well, Dr. Gensler, sometimes people make fun of me and they say I'm inherently unmarriable. Would that be that form? Yeah. This is kind of insulting if you say this one of a person. If you're a bachelor, then you're inherently unmarriable. No possible world would anyone marry you. So if B, then U by itself is necessary. Whereas the conditional necessity says what is necessary isn't that you're unmarried, but it's the connection between being a bachelor and being unmarried. It's necessary that if you're a bachelor, then you're unmarried. So what's necessary is the whole if-then, the connection between the parts. This is more likely true because by bachelor we mean something like unmarried person or unmarried adult male or something like this. So this is true by virtue of what we mean by bachelor. It's necessary that if you're a bachelor, then you're unmarried. Now, does this one take away your free will? No, but this one does. Poor Joey. If this is true of him, if he's a bachelor, then he's inherently unmarriable. If he is a bachelor, then there's no way he could get married. No possible world would anyone ever marry you. Do you feel that at times, Joey? Let's not get too personal about this. Okay, I'm sorry. Now the conditional necessity. It's necessary that if you're a bachelor, then you're unmarried. These parts could change. Maybe you're a bachelor one day and then you're married the next day. And then, like movie stars, sometimes you get unmarried the next day. So it could change one day from the next, whether you're a bachelor and whether you're unmarried. But the connection between the parts would always remain. It's necessary that if you're a bachelor at a given moment, then you're unmarried at that moment. Okay, so which does the English mean? Well, it could go either way. It's not exactly clear. Usually, what it means is this, the conditional necessity, which is the less outrageous version. But sometimes it could mean this, the simple necessity. Now, in philosophical arguments involving this form, the if, then, must, where the premise could go either way, it could be box inside, box outside. There's a lot of arguments like that. And where you meet one, you got to say this premise could mean this or this. And then you work it out like two separate arguments. I mentioned the divine foreknowledge, human freedom argument. If God knows what we are going to do, then we must do it, and so we can't be free, etc., etc., etc. That involves this ambiguity, and it's really two arguments. Is it a good argument? No. We will talk about that later. So, if you see something of this form, say, could mean box inside, could mean box outside. Now, it's somewhat difficult to know which is which to use, which forms are ambiguous. These forms aren't ambiguous. If A, then B by itself is necessary, means the necessity goes on the second part. If A, then B is inherently necessary, again, the box is on the second part. These are somewhat artificial forms to give us a clear way of saying the box inside in English, which English doesn't permit us to do very well. Now, these four forms in English are all box outside. A entails B. It's necessary that if A, then B. Necessarily, if A, then B. If the first word is necessary, then the box goes outside. It's necessary that, if A, then B, same thing. If A, then B is necessary truth, you're saying the whole thing is qualified by being necessary. So don't say they're all necessary. When you do the logicola proofs, you have an ambiguous one. In the type the answer exercise, you got to type da 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 or da 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 da. But don't do it always, it will mark you wrong. These aren't ambiguous. Which forms are ambiguous? Well, two forms. If A, then it's necessary that B, and instead of necessary, you could say that it must be that B, or something equivalent. Could mean box inside or box outside. And if it says this, if A, then it's necessary that B, you got to do it two ways. You got to say it could mean this or this. And with the arguments, you have to express it two ways. It becomes, the English argument is ambiguous between two different arguments. There's another variation. If A, then it's impossible, or couldn't be that B, could mean A implies box not B, or it's necessary that if A, then not B. Here, if A is true, then B is inherently impossible. And you could say possible, not possible B instead there. Or it could be that what's necessary is a relation between the parts. Necessary that if it's A, then it's not B. Okay, this is somewhat confusing and difficult, but again, you'll master it, especially with more examples and with the Logicola ones. Okay, 4 more translations. I had you do up to 14. It's not possible that there's evil. Okay, evil couldn't be. It's impossible. Or you could also say necessary, not evil. You have to do two ways. No, you have to do the or if it's ambiguous. Instead, just pick one. It's possible that there's no evil. Okay, we could imagine a possible world in which there's no evil. Could we do that? Well, I don't want to get into that. This is just logic. Now, Annie, how could you do that with a box? Well, you could say, not necessary. Right, brilliant. Instead of saying it's possible that there's no evil, you could say it's not. It's possible that there's no evil, you could say it's not necessary that there's evil. Now, this one's a little tricky. If you get more points than your opponent, then it's impossible for you to lose. Now, this could be box inside, outside. It's necessary that if you get more points, then you don't lose. This is the form that makes more sense. What's necessary is the connection between the parts. It's necessary that if you get more points, then you don't lose. Whether you get more points or not might be a matter of chance, or could happen either way. Maybe you could lose, you could win. What's necessary, though, is the connection between the parts. Necessary that if you get more points, then you don't lose. Or the alternative form is if you get more points, then it's necessary that you don't lose. And instead of necessary that you don't lose, you could say not possible lose. And this one would take away your free will, actually. Suppose you lose. Or suppose you get more points than your opponent. Then you couldn't have lost in itself. But you could have lost because you could have gotten fewer points. This would take away your free will. If in the actual world you get more points, then you couldn't have lost. Now, what's necessary is that if you get more points, then you don't lose. But that doesn't make your losing inherently necessary, because you might have failed to get more points. That's a little confusing, but hey, you've been confused before in class, and you've survived. And then the last one I had you do is 14. It's necessary that if you see that B is true, then B is true. What's necessary is the if then. If you see that B is true, then B is true. Is this ambiguous? No, because the necessary is at the beginning. Here you have if, then impossible, which makes it ambiguous. It's necessary that if you see that B is true, then B is true. Okay, that's enough for today. Homework for the next unit, do a few more translations on page 233, and just a few more. We'll go through them in class, and then read ahead. And this is about how to do proofs, and we'll see that they're kind of nifty. They involve possible worlds and all kinds of cool stuff like that. And then also do Logicola J. J is modal translations. And you have the basic ones, multiple choice, and type the answer, and do both of them. And again, with the ambiguous ones, you've got to give both answers. With the multiple choice, that's one of the answers, is da-da or da-da. With the type the answer, you got to type it yourself, and so forth. So, okay. Skip these two. These are for a more advanced course. The quantified modal logic. And we're not getting into quantificational logic, and even more so, we're not getting into quantified modal logic. So the only proof translation exercises that you'll have are the more basic ones. So you want to really master that by next class or next unit. Okay, so bye-bye, and I'll see you then.